Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we are going to continue our decline curve analysis series. And today's topic is about conditions for water flood decline curve analysis. All right, so I take this piece of information from this very interesting book, very popular book, Reservoir Engineering Handbook by Tarek Ahmed. All right, so let's learn together. And I'm going to read this whole thing. Okay, and let's learn together. All right. The natural production decline rate of oil is related to and impacted by the decline in the reservoir average pressure, as well as the degree of gas liberations in oil reservoir. Okay, so this is a very important thing, and this will distinguish the natural decline with water flood decline. Okay, so I'm going to highlight this. Natural production decline is related or is dependent on or impacted by decline in the reservoir pressure, as well as the degree of gas liberation. So if you have oil reservoir that is not supported by water flood or strong water drive, something like that, water injection, it will experience what we call natural production decline. And the main driver of this natural decline is the decline in reservoir pressure, as well as the continuation of gas liberation, which in return will further reduce the reservoir pressure. That's the main driver of the decline. However, if we have now water flood, water injection, the reservoir pressure is generally tended to be kept at a certain level to maintain a voidage replacement ratio of 1. Right, so VRR, voidage replacement ratio of 1, is one of the main KPI in water flood. Okay, key performance indicator of water flood is basically you want to maintain the voidage replacement ratio equals to unity. Okay, and by keeping VRR of 1, okay, you will stabilize the reservoir pressure. You will make reservoir pressure relatively constant. Okay, so now the change or the decline in reservoir pressure will not be the main cause of the natural decline. Why? Because we have the reservoir pressure being supported by the water flood. The reservoir pressure will not change significantly. It will be relatively stable, relatively constant. All right, go to the bullet number 3. Therefore, the decline in the oil rate in water flood, okay, is governed by the reduction in the oil saturation and consequently reduction in its relative permeability. All right, so this is a very important thing. In water flood, the main driver of the oil production decline is not reservoir pressure, but the reduction in the oil saturation, which will reduce the relative permeability to oil. All right, so you can see the difference between natural production decline and water flood production decline. In natural production decline, the key driver of the decline is the decline of reservoir pressure. But in water flood decline, the key driver of the decline is the decline of oil saturation and the reduction of the oil relative permeability. Okay, this indicates that the oil production rate in a reservoir under water flood process does not directly depend on time or pressure, but it depends on the water injection volume and water injection rate. This is very important. Volumetric sweep efficiency, relative permeability ratio, and maximum allowable total production rate. Maximum allowable total production rate. Okay, in other words, if you have, change in your water injection volume, change in water injection rate significantly, and then also the change in production rate, or if you have volumetric sweep efficiency that is keep changing continuously, basically that's not a very good situation for you to perform water flood decline curve analysis, because now the reservoir condition is not stable. The decline curve analysis has to be applied in condition in period where the reservoir is relatively stable. Okay. And basically the operation relatively stable, the reservoir relatively stable. Now, at that period, you can take the production data and use that to forecast and use that for your decline curve analysis. All right, we continue. And to apply or to develop a decline curve analysis procedure to a secondary recovery process, that is to say the water flood process, the framework and the required criteria as specified by Buckley-Leverett equation for two immiscible flow must be met. Okay, so if you want to perform water flood decline curve analysis, we must put into place this Buckley-Leverett equation for two-phase immiscible flow. Okay, this condition must be met. Ideally speaking, Waterflood-DCA, water flood decline curve analysis methods must meet some strict conditions related to this Buckley-Leverett, including only applied after water breakthrough. Okay, and when the water-oil ratio greater than 5 or fractional flow of water greater than 60%. FW, fractional flow of water, is actually the water cut. Okay, so if you have W or R greater than 5, or which is simple one, the water cut greater than 60%, then basically that's a good condition for you to do the decline curve analysis. But if the reservoir, if the water cut is still low, then that's not very good for you to perform decline curve analysis. And this is very important. Injection rates remain stable. Fluid production rate remains stable. Okay. Voidage replacement ratio, VRR, is close to or equal to 1 unity. And the cumulative water injected should be greater than 25% of the hydrocarbon pore volume. All right, it's quite strict, but yeah, you can find all of these conditions met during the production history. Okay, although it's not very ideal, but still, practically speaking, you can take that period of time to perform the decline curve analysis, where these 6 conditions are met. Okay, more or less. Okay, you cannot be very strict actually in reservoir engineering. All right, there we have abundance of uncertainties. Okay, so it's good to follow these 3 conditions, but maybe you can negotiate a little bit. Okay, and it's not very difficult, but basically you can find the period where the water breakthrough has been achieved, high water cut, and injection rate, production rate remains stable, VRR equals to 1. Yeah, it's quite strict, but that's relatively easy to find during the production history. Okay, and I think that's basically it. All right, so this is the conditions for water flood decline curve analysis. Thank you so much for watching, and see you again in the next decline curve analysis series. Thank you.